right, greetings, RTVFX crew. Today we kind of had a catastrophe and a bit of a disaster as far as demoitis and things not going well. But as promised, I have come up with a resolution on how to resolve these things. And one of them was that we had no way of exporting our data because we spent our time trying to get the explosion working, and it's a lot of fun because we got the demon door blowing the dickens out of things. Oh, there it is. We put this on the bullet solver, and there it is. So I hit the outdoor, and then it just kind of blows up there. And so that's a lot of fun, and we're just kind of playing around with this. And so what we could do is like, let's figure out what we did wrong and what we could do to move forward and get things going. So we're going to start here with the material. And so here's the material, everything's going on. And then so we had a problem here with the attribute delete. Actually, we had in here, it was, I am sorry, there was a there was a note in here. It's called package. Package, no. It is, right, it is an assemble SOP. So what we had to do is we put an assemble SOP in here. And this was going to make things a little bit tighter because notice that I'm going to put that right in here. And notice that with the material, if we were to look at the number of objects here, that this is roughly 5,900 points and about 20,000 vertices and about 4,700 vertices, polygons. So it's a lot of information. So when we put it into the assemble here, the assemble kind of packages things up. And I don't know if I told you this, but when you put down the assemble, you gotta put down the create pack primitives. So when you click on that, what that does is it transforms it into objects. It's no longer, so every single piece that gets broken apart is gonna be its new object. So if we look at this, we see that it's now 260 objects. And so there's 260 objects floating around here. And here's the interesting part here is that in class, now I said, okay, what we have to do is we have to remove the attribute. If I click on the attribute delete, we had UV2, UV3, UV4 getting removed. Okay, but the problem is that once the object has been packed up, then it's no longer, you can't modify and manipulate the attributes anymore that have already been packed up. You can do things afterwards, before, but it can't really do that. So what I'm going to do here is I'm going to move this over here, this attribute delete. I'm going to push this down over here, and then I'm going to move this and then put the attribute delete before the assemble. And so now when it gets assembled, the assembled object does not have those UV2 objects inside of it. And then we put in the point velocity, and then we click on hit, and then if we put this into the RBD bullet solver, everything should work as expected. So that's a lot of fun. But we're now going to try to export this out to VAT. Now I realize that you don't have VAT, but I wanted to at least go through the process to show you how VAT's done. So if we go up here, we created our output door, and if we drop inside of that, we have the VAT operator, and we have our input object is outdoor and so forth. But notice that we're getting no more warnings. And that's exactly what we want. We want everything to be nice and clean. And so now if we go ahead and save this and then hit render all, we will be able to get going good. But you folks don't have this capability in Houdini, and there's no guarantee I'm going to be able to get this going. And so I'm not going to go too much more into it until I know that we do have access to Houdini. And so but just know that we did successfully output the object and its output textures, so it would potentially work. Hopefully I'll have a chance to show you how VAT works, because at the end of the day, VAT is going to give the artists more opportunity to control the simulation and control how it behaves within the context of the game. However, I was reminded today that we don't have only VAT in order to export the geometry. We could use something called Alembic. And now Alembic is an alternative to FBX. The Alembic will store the information and get it so that we want it in just the way, and it will store the animated data, which is something that FBX cannot do. So what we're going to do is I'm going to go back up here and go back into the stage and prepare this for out there. So the outdoor, in fact, the outdoor here is, I'm going to call this out VAT door. So that we know that it works. I'm going to come back up here into the outdoor. And so it's the change propagated through out VAT door. All right, now let's go into here. Now, we're not quite done yet, so we've got the bullet solver here. What we have to do now is configure this to work with Alembic. Now, Alembic has some peculiarities, and one of those, it doesn't handle anything more than quads. It can only handle triangles and quads, and that's all it can handle. And then, so therefore, in Houdini, what we're going to do is we're going to convert this material object here, and it's got some elements that are some 5 and 6 vertices wide, and we're going to make that so what we're going to do is, off of this material, we're going to append a triangulate saw. Let's see, triangulate, and we're just going to slip that in there. And so it's now triangulated. And so that gets rid of anything, and it says the maximum number of edges are 3, and that's exactly what we want. And we want all of our polygons to be convex. Now that's very important. It's impossible to get a concave polygon with 3 points, but we just are choosing convex polygon because we know that that has to be done. And we want to say triangulate non-planar. So this guarantees that all of the output polygons are going to be planar, which is exactly what we need. And so now we're ready to output, but we're almost not ready to output, because what we had to do is, remember how at the beginning of this whole situation, we had to shrink this down by 100 times in order to work with it and to get the simulation correct? Well, what we have to do now is we have to return it back up to its size so that Unreal can handle it. Now, you wouldn't have to do this if you're using VAT, but since we're going to be using Alembic, we're going to need to scale it up. So off of this node, I'm going to pull that out. I'm going to drop in a transform SOP. Okay, transform, and then we're going to call this scale up UE5. Okay, so scale up UE5. Wait, that says A scale. Come on, we just want regular scale. Scale up, no. Get that up, scale up UE5. And so I'm going to click on that. I'm going to hit the display, and everything is going to be exactly the same until we put, for the uniform scale, we're going to put 100. And then everything's going to disappear. Why? It's because the entire scene has been scaled up 100 times. But if we hit the F key in the display window, there is our door, and it's looking fine, but it's now much, much bigger than it was before. Let's test to see if this still animates. It should, because all the animation was done at the proper scale. Okay, so everything seems to be working apparently. All right, so we are good to go with that. Now the last thing to do is I'm going to put a null here. And then I'm going to call it out underscore ABC underscore door. Okay, so that means is that we're going to be doing the output for the door on here. And we're just going to display this. Now, unlike the ROP there, we could use the ROP. Let's see. Could we use the ROP there? Yeah, let's see. We've got this ROP, the output door. So let's double click into here. So we have our vertex animation, and I'm going to name that VAT door. So that's the door. But in this network, we can have more than one output way. And so what we want to do is I want to create this. Let's see if we have Alembic. Let's see. Geometry, image, farm dependency, managers, scene, bake animation, no. Alembic, no, this isn't going to be what I want. Okay, so let's just go back to the stage. And right off of this ABC door, let's run off here and put down a ROP Alembic output. Honestly, I don't know what the difference is, but for some reason there is, and we'll have to talk to the Houdini folks about it. And so the Alembic file, we're going to change this from a valid frame range. We're going to put that to render frame range, so that should be 1 to 100. Render with take, we're going to leave that here. As for the Alembic file, hopefully we're still working in the same project, so we're going to put $job output Alembic, and so I'm going to say $job ABC slash, I'll call this demon door .abc. Oh, just in case your system doesn't know what job is, don't forget to go here to File and then Set Recent Projects, and hopefully you've got the recent project in here, or Set Project, and then go to where the go to the location of where it is on the disk, and here I put it on my location, RTVFX RBDS, and make sure that that is selected as my project and click accept, and that should clean everything up. Now what we have to do here is we've got the $job means it will export to the location, to the ABC folder called Demon Door ABC. Let's go ahead and save this. And hopefully we should be okay. So what we're going to do is say save to disk. Okay, there it is. And so this exported now, if we take a look at this folder here, and we're going to go up here to class demos, Houdini, RBDs, and okay, here's my ABC folder, and there's my Demon Door ABC. Now notice that when you export with Alembic, the size of the output is really huge. And so this is 127 meg. So it's not that big, but it's certainly a lot bigger than if you were going to be using the Vertex cache. Now the Vertex cache is disgustingly cheap. That's why it's another reason why it is very desirable. But this is pretty good. And so we've got their Demon Door ABC to be used. So with this ABC file, let's go ahead and push this into Unreal. Okay, come on, come on, go. Oh, I must not be in the right window yet. Okay, there we go. All right, so here we are in Unreal, and this is the RTVFX Destroy 5.2 scene that we have here. And so let's go ahead and just see if we can import this. So I'm going to go in my content drawer, and then I'm going to create a new folder called Demon Door. And I'm going to drop inside of this. And then I'm going to grab here's my folder. I'm going to grab my Demon Door object and then drag and drop that right into the scene there. All right, so notice that it came up with a whole bunch of stuff, and it's kind of complaining about a bunch of stuff, but otherwise it's okay. So where the input type is, make sure to change it from static mesh over to geometry cache. That's very important, because remember we're dealing with caches of geometry, and a frame starts from 0 to 100, and we're just going to leave it as is. And then preset, Autodesk Maya, create materials, find materials. And so we're going to actually create new materials based on that. And then click import. Okay, so this is going to take a little while because it's actually locating a lot of information. But here we have the demon door, honestly, on there. Okay, and what the demon door needs, it needs some materials. But ultimately, we're going to create a variation of just one material. So I'm going to click on here, create a new material, and I'm going to call it M underscore door. All right, we've got the M underscore door. Let's look at the contents of this. All right, we want this to be nice and simple, but we are going to want to have a variable texture driving this. So I'm going to create a texture parameter 2D, and I'm going to call this door texture. And I'm going to push this right into base color. Now, what we have to do is I'm just going to quickly whip out a couple of constants because we want this to be stone, and the stone is going to be rough and not very specular. And so we definitely want to grab the metallic and make that a 0. So I'm going to drop in a constant just to be quick, and then I'm going to put that into the metallic as we don't want it to be metallic at all. And then from this, I'm going to drop down a 1 minus. Come on, give me 1 minus. There we go. And now I'm going to put that 1 minus into the roughness. And so that's going to make it look kind of matted, kind of confused, a little sketchy in here. Now, if we had normal maps or world position offsets, we could put that in here, but we're just going to leave that as is for now. So I'm going to go ahead and save that. And let's create the variations. Remember that we had the insides and the outsides. So that's why we have two different materials here. So for the M door, I'm going to right click on here, create a material instance, and I'm going to call this MI door outside. And let's drop into this. So here's my MI door outside, and the only thing I'm going to change here is the door texture. And I'm going to change this, and I'm going to look for, something like granite. I think there's a granite texture someplace. Okay, T-Rock smooth granite. Okay, that's what we want. Okay, so we've got the granite in here. All right, so I'm going to click on save. And so the last thing I'm going to do, let's do it for the outside. Let's do it for the inside. So I'm just going to create a right click, create another material instance. And I'm going to call this MI underscore door underscore outside. Oh, MI already called door outside. Okay, I'm going to just call this. Oh, we have to do it. I switched these around. Oi, joy, oi. Oh my. Okay, I'm gonna call this inside. I'm gonna make this all caps. And so I'm just gonna change this around. So this one, I'm gonna double click, and I'm gonna call this one granite because it's on the inside. Save it, and then I'm gonna come on here to the door to the outside. Okay, the outside one, we're gonna change this, and we're gonna look for demon door. Demon door, there's T-Plains Ruins Demon door. All right, hit save on that. And then we hit the first person map. And we should be good to go. So if we go into the content drawer and then throw in the demon door inside of this level, notice that it comes in sideways. And that's another disadvantage of the Alembic is that it's always coming in sideways. So we're just going to rotate this guy 90 degrees in the X direction. And we're going to move it aside. And then you'll notice that it has two materials. And then how convenient. One for the inside, one for the outside. I believe the outside is first. So we're going to click on this world material and click on outside. So this is door underscore outside. No, I think this is the inside. Yeah. Inside, door inside. And then I'm going to click on this other one. So I'm going to look for door outside. Okay, it looks like that more or less happened. Now, here's another drawback of using Alembic. You can only see it animating in play. So if we go ahead and hit play, oh, there it is. Whoa, it's blowing stuff all over the place. Okay, so it is working, and we have two different textures, one for the outside, one for the inside. Okay, so what we'd have to do is put this into a blueprint and create a collision object in order to activate all this. So this is exactly what we're looking for. All right, so let's actually put this into the level now. So I'm going to go in my content drawer, and I'm going to go to the content. Oh, I'm going to go and save all these three before doing anything. Yes, Control Select all three, hit Control S to save them all. Now for this, I'm going to go to the Elven Ruins. So I'm going to type in Elven, the Elven Ruins. So I would double click to go into that. Save selected. Okay, there is the old, there's the demon door. I'm going to go ahead and delete that. And so now what I'm going to do is content drawer. I'm going to go back to my drawer, content, and then where we have the demon door. And here's my demon door object. I'm going to put that in there, kind of rotate it into place, but before so we got to rotate it in X 90 degrees. And then I'm going to do my best to kind of shimmy and push that into position. Move that over just a bit more. Drop it down just a tad. All right, so, oh, I'm going to move that over just a little smidgen. Okay, so it's sitting in the door, so let's go ahead and grab the materials. For this one, we have the door inside. And for this, we want the door outside. Okay, there's our door. We can't see this until we actually activate it, so let's go ahead and play in the game. And good lordy lord, we're going to have to go do the long path all the way to the back. That'll teach me not to move my initial starting position. But we can start to see already that it's quite going robustly. Okay, so look at that. It's bouncing around all over the place and then bouncing onto the area, so it's behaving well. So the only thing that I would have probably done is this. I would have put in arches right at the beginning so that the pieces bounce against the arches and then bounce against these arches and pillars going on here. So we'll have more to bump in. So what I would do is I would re-export this object in order to get the arches and pillars and then automatically insert it into the Houdini network. It'll drop right in. And then what we could do is put in some pillars and some arches to give it some kind of simple objects to bounce against. And that would be really easy to manipulate. Okay, gang, thank you very much for your attention. Thank you very much for your patience. Sorry for not being able to deliver this content in the context of our lesson, but you never know until it's too late. So thank you very much for all of your patience. Have a great GDC, and I'll see you when you get back from, oh yeah, when we get back from spring break. Remind you that if you only choose to use two objects and they're both chaos objects, that will be totally fine. But if you want to play around and use the Houdini and use the cache method in order to break things up, that will work too. So either which way is fine. And just know that you don't have to do the cache method. You could use two chaos objects, just as I said before. Okay, thank you very much for your attention, and I look forward to seeing you after spring break.